The question here is asking us to determine all the reaction and member forces, and we're going to do this by using the method of joints. So here first we need to determine what forces are the diagram. So at the pin here we have an AY and an AX force, and at the roller we have a DY force. So let's go over here to the diagram on the side. So here we have an AX and an AY dy and the slopes of each one of these lines. So in order to solve for AX, AY, and dy, since there are two forces at A, we might as well do the moments about A equal to 0. And using that formula, we can find dy as 3 kips. The next step is to use the sum of forces in the x direction. So we have AX going to the right, 1 kip here, and solving for AX gives us -1. Well, the negative sign just tells us the assumed direction was wrong, so this is actually 1 kips going to the left side. And the sum of forces in the y direction equal to 0, so AY minus 2 kips plus 3 kips or dy that was solved here, and AY equals to -1 kips also tells us the assumed direction is also incorrect. So this is actually 1 kips going down. So the next step is to find the member forces. So here we can have, let's say, joint D. So using joint D, the sum of forces in the y direction only about joint D. Now we're using the method of joints. We don't care about all the other forces, just the forces acting at that point. So here we have 0 equals, well, dy going up, and also I'm assuming all member forces to be in tension, that is away from the point. So FCD will actually be going up as well at a slope of 1 over square root of root 2, or square root of 2, I said square root of 2, and FCD. Well, we know what the value of CD is. Plugging in back the value, we can solve for FCD as -3 root 2. Well, since we assumed all forces to be in tension, this would actually be 3 square root of 2 in compression, because that would be pushing on the point. Now we can find the sum of forces in the x direction. That would enable us to find the force in AD. So that's negative FAD, since I'm assuming everything to the in tension, so this is away from the point. So this is FAD plus, well, 1 over square root of 2 FCD, because this is going to the right. So here we can plug in back the value for FCD that was found here and solve for FAD. So FAD gives us 3 kips, and this is in tension because it's positive, so the assumed direction was correct. For this next one, we're going to use the joint B here. So the sum of forces in the y direction is, well, we don't know if it's up, we're just saying tension. So the sum of forces in the y direction about point B. So 0 equals to FBC, that's in the x direction, so we can't use that. We have -2 going down, so this is -2 kips, minus 1 over square root of 2, also going down, and this is FAB. So solving for FAB here, that gives us negative square root of 2 kips, which means this is actually 2 square root of 2 in compression. And then the sum of forces in the x direction. So we have FBC going to the right, and we have negative 1 over square root of 2 FAB. Since we already solved for FAB, we can go ahead and plug this value. No, actually, we should be using a negative value here. Plug that into FAB, and FBC results to negative 2 kips. Since this is negative, this will be 2 kips in compression. Just to keep track of what we've done so far, just put a mark on everything we've solved for. So here we found FCD and FAD. So FCD and FAD has been solved for. What else? FAB and FBC has been solved for. So FAB and FBC has been solved for. So all we're left with actually is FBC. So for FAC we would be using, let's use C. We'll be using joint C as the point we're using as our moment point. Joint C. It doesn't matter, you can actually use A as well, but I'm just going to use C. So for joint C, sum of forces in the y direction equal to 0. So 0 equals to negative 1 over 5 FAC. This is FAC right here, and this is 1 over 5 because it's going down 1 over square root of 5 actually, FAC. And we also have negative 1 over square root of 2 FCD right here. So we have this and this one. We don't care about BC because it has no y components. So this is FCD. Well, we solve for FCD first. We know what FCD is. So we can go ahead and plug in that value for FCD, which was negative 3 square root of 2, if I'm not mistaken. FCD, yes, negative 3 square root of 2. So we go ahead and plug that back in. And now we can solve for FAC. So solving for FAC gives us 3.00 kips. And then we put the 1 over square root of 5 here by moving this to the right, and negative 3 square root of 2 cancel out. So multiplying both sides by square root of 5, my answer will be 3 square root of 5 kips. And since this is positive, this is in tension.